questions 1 through 10 on the 2019 grade 10 AMC 10B. Alicia had 2 containers. The first was 5/6 full of water, and the second was empty. She poured all the water from the first container into the second container, at which point the second container was 3/4 full of water. What is the ratio of the volume of the smaller container to the volume of the larger container? So we have one container, and we have another container that perhaps is a little bit bigger or a little bit smaller, I'm not sure. But there's 5/6 in terms of the ratio fraction of water in this first container. So let's just say that we have a capacity of 6, so 6 liters is the full, and this therefore represents 5 liters, let's say. And that's why it's 5/6 full of water. Then you put that 5 liters of water into here, and when you do, it becomes 3/4 full of water. So 3/4 of X, which is the capacity of that container, is 5. So X is 20/3. So now we're basically asked to find the ratio of those two numbers. So 20/3 is a little bit more than 6, so that means this is the smaller one. So the smaller over the larger would be 6/20/3. Invert and multiply, and you get 6/1, 3/20, and that's 18/20, and that's going to be 9/10. So number 1, the answer is D. Consider the statement, if n is not prime, then n minus 2 is prime. Which of the following values of n is a counterexample to the statement? Well, when you go through these, n is not prime. Well, that is prime. That is prime. Okay, so that eliminates A and C. The rest are not prime. This is not prime, this is not prime, and this is not prime. Now let's look at the n minus 2 part. N minus 2 here is 13. Here's 19. Here's 25. Is n minus 2 prime? Yes, yes, and no. So this is the counterexample. Number 2, the answer is E. In a high school with 500 students, 40 of the seniors play a musical instrument, while 30% of the non-seniors do not play a musical instrument. In all, 46.8% of the students do not play a musical instrument. How many non-seniors play a musical instrument? We have 500 students in total. So some of them are seniors and some of them are non-seniors. And then of the seniors, they're saying 40% play an instrument. And I guess obviously the other 60% don't play an instrument. And then of the non-seniors, they're saying that 30% do not play an instrument. So 30% no instrument. And then obviously the other 70% play an instrument. All right. So what else do we know? 46.8% of the students do not play a musical instrument. So mathematically that means 0.468 times the total, which is 500 students, do not play a musical instrument. So that's these guys and these guys. So we actually don't know the distribution of seniors and non-seniors. So I'll just say that the seniors is represented by X, and the non-seniors obviously would be 500 minus X. So I can put that in 0.6 times 500 minus X, and then it would be 0.3 times X. So when you multiply this out, you get 300 minus 0.6x plus 0.3x equals 234. And then when you collect like terms, this is 66, and it will be 0.3, and therefore x would be 220. So x is 220, and what do we want? We actually want this one. So that's 70% of x, so 0.7 times x, x is 220, and that is 154, and that is what they're asking for. So 154 for number 3, that would be B. All lines with the equation ax plus by is equal to c such that a, b, and c form an arithmetic progression pass through a complex point. Common point. What are the coordinates of that point? So ax plus by is equal to c. And a, b, and c, I'll put it over here, are an arithmetic sequence. So if this is a plus d, and this is a plus 2d, like that. So you have ax plus a plus dy is equal to a plus 2d. So let's expand this now. Let's see what we get here. Ax plus ay plus dy is equal to a plus 2d. Let's see what I can do here. I'll just put the d in one place, so dy like that. And then I'll factor out the ax plus y. I'm trying to get them to look similar, the left side and the right side. Okay, so that means that this has got to be 1 in order to match that. So x plus y has to be equal to 1. And for this to match this, that means y must be equal to 2. Okay, so if y equals 2, I can sub that into here. So x plus 2 is 1. So therefore x is negative 1. So my point xy is negative 1, 2. And there you go. Number 4, the answer is A. Triangle ABC lies in the first quadrant. Points A, B, and C are reflected across the line y equals x. 2 points A dash, B prime, C prime, respectively. Assume that none of the vertices of the triangle lie on the line y equals x. Which of the following statements is not always true? So, as always, we got to create some extreme case scenario to make one of those not true. So, let's just draw our graph first. Y equals x would go straight down the middle like that. And now let's just see what we can do here. Let's draw a couple triangles. And let's label this now. This one's A, this one is B, and this is C. And then when you reflect it, this is A prime, B prime, and C prime. Okay, let's see what we get. Triangle A prime, B prime, C prime lies in the first quadrant. Okay, that seems to be true. Triangles A, B, C, and A, B, C, the prime, have the same area. Yeah, it's the same. It's just reflected, so that would be true. The slope of line A dash, A prime, is negative 1. And I think that should be true, since it would most likely be perpendicular to y equals x, and y equals x has a slope of 1, so the line perpendicular would be negative 1. So that should be true. The slopes of A prime, and C prime are the same. And I see that would be a line through there. And yeah, it looks like they're parallel. So if they're parallel, the slopes would be the same. Okay, lines AB and AB prime are perpendicular to each other. So AB is here, and A prime, B prime is here. And those are parallel, so they're not perpendicular. Okay, so we got a very clear picture of why E is not true. So number 5, the answer is E. A positive integer n satisfies the equation n plus 1 factorial plus n plus 2 factorial is equal to 440 times n factorial. What is the sum of the digits of n? Well, n plus 1 factorial plus n plus 2 factorial is equal to 440 times n factorial. Okay, so let's see what we get. N plus 1 times n factorial, when I break it up like that. Then n plus 2 times n plus 1 times n factorial, when I break it up like that. And this side will remain the same for now, n factorial. Well, the good news is the n factorial cancels from all, so all we're left with is n plus 1 plus n plus 2 times n plus 1 is equal to 440. So now let's expand this. And when we do, we get n squared. Well, this is just n plus 1. And this would be plus n plus 2n plus 1 is equal to 440. Let's put everything on one side. N squared plus 4n. And then it's going to be 3. Sorry, this should have been a 2. So it's 1 plus 2 minus 440, so minus 397. Minus 437 is equal to 0. Now let's factor that, and when we do, we get 23 and 19, positive, negative. So therefore n is going to be 19 or negative 23, but n is positive, so it can only be the 19. And the sum of the digits of 19 are 1 plus 9, which is 10. So number 6, the answer is C. Each piece of candy in a shop costs a whole number of cents. Casper has exactly enough money to buy either 12 pieces of red candy, 14 pieces of green candy, 15 pieces of blue candy, or n pieces of purple candy. A piece of purple candy costs 20 cents. What is the least possible value of n? So we have 12 of the red, 14 of the green, 15 of the blue, and n of the p, which is purple. And all of these prices multiplied by the number of candy is going to be equal to the same number. So that means that we have to pretty much find the lowest common multiple or least common multiple of these numbers. So for the purple, we're not told how many, but we are told the price, and that price is 20. So I'm going to find the LCM of these numbers right here. Well, 12 is equal to 2 times 2 times 3. 14 is equal to 2 times 7. 15 is equal to 3 times 5. And 20 is equal to 2 times 2 times 5. So here we go with the LCM. For 2's, it appears maximum twice, so I have to put it twice in my LCM. 3, it appears maximum once, so I'll just put it once in the LCM. And then 5 appears maximum once, and 7 appears maximum once. So this is my LCM, 4 times 3 times 5 times 7, and that is 420. So now to get the price, I just divide 420 by the number of pieces. When you do, this is 35. 420 divided by 14 is 30. 420 divided by 15 is 28. And then for purple, I just divide 420 by the price to get n. And 420 divided by 20 is equal to 21. So n is 21. So number 7, the answer is B. The figure below shows a square and 4 equilateral triangles, with each triangle having a side lying on a side of the square, such that each triangle has side length 2, and the third vertices of the triangle meet at the center of the square. The region inside the square, but outside the triangles, is shaded. What is the area of the shaded region? The region they are referring to is right here. It is a little shaded, but you can barely see the shadedness. So there we go. That's what we have to find out. It's an equilateral triangle, so I guess I can write or draw a perpendicular down to here, and one more up here, and that should be pretty straightforward to figure out the dimensions. So that's a right angle. So here we go. I'll just call that H from here to there. So as always, this is going to be 60, and then this will be 90 in an equilateral triangle. And the ratio of the sides are, as always, root 3 to 2 and 1. So that means 2 over h is equal to 2 over root 3. And therefore h is equal to root 3. So that means if h is root 3, then this is root 3 also. So the top to bottom is actually 2 root 3. So that means the side of the square is 2 root 3. So the area of the shaded region is really the area of the square, which would be 2 root 3 squared, minus 4 of those equilateral triangles. So minus 4 times 1/2 base times height. The base is 2, right, from here to here. And the height we just figured out was root 3. So this is what? 2 times 2 is 4. 4 times 3 is 12. And this is 4 root 3. 12 minus 4 root 3. And therefore, number 8, the answer is B. The function f is defined by f at x is equal to bracket absolute value of x minus absolute value of bracket x. For all real numbers x, where bracket r denotes the greatest integer less than or equal to the real number. What is the range of f? Just in case you're not familiar with bracket, I'll just give you an example. Let's say I have bracket of 1.5. It would be the greatest integer less than or equal to that, which in this case is 1. Let's say I had the bracket of negative 2.5. Be careful, the greatest integer less than. So that would actually be minus 3. Alright, so what I like to do in these kinds of questions, just plug in some numbers and then see what kind of values you get for f at x, and then that would give me the range. Or you can do it in a more scientific way. It's up to you, really. I'll do it in a more scientific way just to be a little bit more convincing. So I got 3 scenarios, right? X greater than or equal to 0, or x less than 0. And when x is less than 0, it can be either an integer or it can be not an integer. All right, so let's start with the first one. If x is greater than or equal to 0, then f at x would basically be, the absolute value would just make it x, so it would be bracket of x like that. I'm doing this right here. And then minus, since it's positive, the bracket would just stay, and the absolute value would not make a difference since it's positive. So that would just give you 0. Okay, straightforward enough. Now let's go with x less than 0. That would give me f at x. If x is less than 0, then it would be bracket minus x. And this one, since x is an integer, it would just be x. But then when you take the absolute value, it would actually be minus x again. And this is just minus x. Since it's an integer, we don't have to do anything. So it's minus x plus x, which again is 0. Okay. Now when it's not an integer, hopefully that gives me something more interesting. When it's not an integer, f at x is equal to, this becomes minus x again, because you're taking absolute value of a negative number. And on this side, it becomes minus the x under the bracket. And then now, because it's not an integer, we have to separate it into x minus 1, and then this just becomes plus bracket x. So the bracket x cancel and you just get negative 1. And in case you weren't convinced if that was a little too abstract, let's just try a number that's less than 0 and not an integer. So for example, negative 1.5. And let's see what we get for f at x. F at x, of course, let's remember the definition right here. So it would be absolute value of x, bracket, minus bracket x, absolute value. So if we're putting in negative 1.5, we would get negative 1.5 absolute value, then bracket, minus absolute value of 1.5 bracket. So the absolute value of 1.5 negative is 1.5. Okay. And then the bracket 1.5, remember, the greatest integer less than that, so that would be negative 2. Bracket 1.5 is 1, greatest integer less than that. Absolute value of negative 2 is 2, and I get 1 minus 2, which is negative 1. So as I got there, I got negative 1. And those are the only the values I can get. It'll be either 0 or negative 1. So therefore, those are the only two, and therefore the range would be, what are the answer choices? Number 9 is A. Negative 1 or 0 are the only choices, only possible outcomes for f at x. In a given plane, points A and B are 10 units apart. How many points C are there in the plane such that the perimeter ABC is 50 and the area is 100? All right, so we have some triangle. Let's just draw a quick diagram here. And we've got a triangle that has some sort of a property. And I'll just draw a height that's perpendicular. I'd like that. And we are told that A and B are 10 units apart, so this is going to be 10. And then this side I'll just call x and this side y. So the perimeter is 50, so x plus y plus 10 is equal to 50. So that means x plus y is 40, equal to 40. And then I'll call this height h, and therefore the area, 1/2 base times height, which is 1/2 10 times h, is equal to 100. So that means 5h is 100, and therefore h is 20. All right, so let's talk about this. From the diagram, I hope you can see that h must be less than x, because x is the hypotenuse of this right-angled triangle. And therefore, x is either less than or equal to y. Now, x would be equal to y. It would be isosceles. If x is less than y, that's one way. We could also do y less than x, but it would have the same result. Let's just talk about this. If that is true, well, h is equal to 20. We just figured that out. If x is greater than 20 and y is greater than or equal to 20, there's no way we could get x plus y equal to 40. For example, if h is 20 and x is greater than that, let's say it's 21. If y is greater than or equal to x, it could be 21 or it could be 22, like that. And when you add x plus y, you're going to get numbers that are always going to be greater than 40. So as you can see, it doesn't work. No matter where you put x or y, this system of equations and inequalities will not hold true. So therefore, the answer is 0. No such dimensions can make the information in the question stem hold true. So number 10, the answer is 0, which is A.